Hello everyone, it's December the 18th. Well, I'll be back. I need to get some water first. Alright, I'm gonna do for December 19th as usual, and this is gonna be our first session today. Well, my hope is I can get the daily challenge done as fast as I can to save some brain cells. And by 9:30, we're gonna do the contest. Alright, today is quite eventful. I cooked 2 meals. Right, the first meal was pancakes. It went pretty well. Pancakes went very well, actually. Well, I shouldn't say very well because I didn't have the spatula for it. So, when you cook it, you need to flip it, and the flipping part is, it was meh. It's not the best I can do. But overall, the pancake came out pretty well. Now, the second one was falafel. I made a mistake. Falafel, I used the chickpeas I bought, like a can of chickpea. It's already seasoned, so it's already salty. I didn't know. And also, I read the instruction wrong. It was a quarter of teaspoons. I put a quarter of tablespoon. So that was a lot of salt. And then it was terrible. It was very, very salty. So that was bad. But anyway, that was interesting. All right, let's go for it today. Decode string. Yeah, I'm only going to do one. Have I done this before? They are recycling. Man, made me mad. If we can do it fast, I'll actually try to do another one. But maybe do an easy one so don't like tire out your brain too much. All right, what is this? I kind of remember. K, an encoded string, where the encoded string inside the square brackets is being repeated exactly k times, and that k is guaranteed to be a positive integer. You may assume that the input string is always valid, no extra white spaces, square brackets are well formed. We can assume that the original data does not contain any digits, and that digits are only for those repeated numbers k. For example, 3a, or these are not going to be. So that makes it very not difficult, right? And as the length only 30. Lowercase is like medium questions. The difficult level is a wide range, right? This I think this you can even say it's an easy question. I don't see how. Oh, now I see. I look at this. So they're asking for recursion. Yeah, I'll do recursion. I'll do recursion. That's fine. That's fine. So basically, we're gonna build a string, right? So we're just gonna read. Yeah, we read it one by one, and we read one by one, and then we add it to the result. And once we hit a or, what would be a better way? Just read it one by one. Okay, let's read one by one. Right? Read it one by one, and the first time we hit a number, right? Then we take whatever is the front and put in the result. Now we are handling the number. So after number, all we need to do as many numbers as possible so we can have multiple numbers. And so we're gonna hit number, we handle all the numbers, now we get this, right? So when we hit this, we go into recursion. I mean, basically we do, right? Oh, okay, it's not that straightforward. All right, it's not that straightforward. All right, hold on. It is recursion. It is recursion, but I need to think it through. I need to think it through. Every time we hit this, we should try to find the end, and I would put the middle into a separate recursion function, and that one will return the string. And when I come out, and then I will handle it. Okay. So what? So we have a pointer, so boom, 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 boom. So we hit the first number, then the previous will get out. And then we will, once we hit the number, then we will keep reading the number. And we get the number. Then we'll get this. And then we'll keep reading until the end, right? Then we have the internal, we throw it into the function, and once it come out, I will use this, create a new one, throw to the answer, and then we'll continue like the same way. Okay. All right, let's try this. Seems promising. Alrighty. Alright, let's see. Decode the string. Alright, so I'm gonna have another one. Oh, actually I don't. I just can have the same thing. That's fine, right? So basically we say rest is equal to this, and for I letter in the numerate S, then we say if letter is a this, right? Well, it says positive, so it's not gonna be it's 1 to 300, so it's gonna be 1, right, to 9. Hold on, let me think. If letter is not, right? If letter is not, then we'll continue. So if letter is in, 1, 2, 3, 4, 5, 6, 7, 8, 9, if letter is in this, right, then when you say rest plus equal to whatever we have for the S up until I, and then we are going to do, oh, this might not be the best way. I think a while loop will be the best way, right? So I'm going to say while, let's say I equals 0, while I smaller than ln s. Now I'm going to say if si, right, is in this, rest plus equal to this, and then count will equal to int si, right, and then while si is in this, which one do you think is faster? It doesn't matter. Count times equals count times 10 multiply the int si, which I realize count should start at 0, right? So it's in, and then I plus equal 1, right? So once we're done, now we got a count, right? Now we have the count. Then what do? Then we have the count. Now si is not in. The first one is not in. That must be the left bracket. So we need to say while s. So we need to say j equal to I plus 1, right? And then we say while sj is not equal to the right bracket, j plus equal 1. Now come out with j as the right bracket. So now we say rest plus equal to count times self dot decode string s I plus 1, and to j, right? So once this whole thing is done, the whole thing is done, I will equal to j, right? So when I come out, I plus equal 1. So which means if I is not inside, then it will just plus equal 1, plus equal 1, plus equal 1. And then if I is in the number, we'll just do all this bunch of shenanigans, and we'll get it, and I will equal to j, which is pointing to the right bracket. So come out, I will move on to 1, right? And once we're done, it is important. Now one more thing. What if there's nothing? It's a good question. That's a good question. We need to have the front, all right? So we actually, okay, we have a j. So let me have a k. Let me have a k as well, all right? Okay, so count is 0, and this one shall be k to I, and once it's done, I equals to j. Actually, k equals to I plus 1. Actually, k will equal to j plus 1, which is the start of the next possibility to start. Okay, so when it come out, I will plus 1, so come up. If I is in there again, right? If I is in there again, then because k already put 1, so this is empty, right? This is empty. And we handle this, blah blah blah. We handle this. So yeah, and at the end, when we break out, we need to do return rest plus sk to I. Okay. All right, let's try our luck. We have this. Yeah, I think this is one of those questions that's, I don't say it's like difficult, but I can sense that there might be some edge cases. But judging from my previous performance a year ago, I don't think there are that many strange edge cases out there, because I got it right in the first attempt. But is my current method the good method? I don't know, but it definitely seems to be a recursion. I definitely won't write it iteratively because there is recursion relationship in this. So it definitely is going to be recursion. The question is just how well I have done this. All right, run it. Oh, we have index out of range. Oh, so while j is not equal to j plus equal to 1. How? How will the j be out of range? Which one? The first one? First one pass. Second one. Ooh. Okay, so what happened? So I got this, right? And then, oh, I hit the first. Dang it. Now I see. Now I see the difficulty part. We need to handle. Yeah. Okay. Okie dokie. Okie dokie. Man. So what are we saying? So we have hit a number, right? Now I say I is pointing here, and j trying to find, right? And j is going to hit the first. If j hit the first, oh, it's actually I going to hit the first number again. Huh. Oh well. Oh well. No, this is not right. Okay, I think up to here is fine. Up to here is fine. And then I think I should just get this entire thing into the recursion from this point on, okay? If we go from this point on, and then we hit this, that's fine. Now we go this point on. And then the first time we hit a right bracket, then we should break out. That's when it ends. All right. Yeah, let's make some changes. Okay, so, I mean, in this sense, maybe we should define a new function. All right, I'm not going to define a new function. I mean, I don't like to do this, but it's fine, right? So we have index, and then k both equal to index, all right? And we say while I is smaller than this, if this is in this number, rest gonna add this. Count is this, right? While this count, blah blah blah. So now we have, let's say we're gonna do decode, right? When decode, it would push in this position in, right? And then push this position in, and we're going to return the value. Yeah, that's fine. That's fine. So what we're going to do is while I smaller than this and si is not equal to the right bracket. If si is equal to the right bracket, then we immediately go out. So if I is not equal to the right bracket. Okay, so we're going to do here. Then we're going to call self.d string s, and the index is going to be I, right? So I comes in, will be here, right? And then with a boom, boom number, we have a count, and then boom, this is I, right? And oh, hold on. If I in this I is not in, no, that should be I plus one, right? And then is not in, I plus equal to 1, right? And then plus equal to 1, then they come out, and the rest plus, okay? So when this comes out, right, then what? Then we just say rest plus equal to, right, count times this, right? Count times this will be your res, right? And after that, we need to handle I. Where is I? That is a good question. Where is I? You need to return something, right? You need to return it. You can't just decode. I need to return not only the string, but also I need to return the terminal position. So I don't know on a return. So I need to return two things. Okay, this is, all right, we have, this is it, helper. We need a helper. Now index, right, and now when you return, that's going to return tuple. All right, not going to return a tuple. Tuple of what? Tuple of str and int, right? And then everything else could be pretty much the same. The rest is this with a ki, and of course we don't need to do this. And then what? Then we go blah blah blah. If this, now I'm going to return this and I, right? Is that correct? So I, when it came out, is going to be either equal length or equals the right bracket, right? Either this or the right bracket. If it's equal to the right bracket, that means when we handle the inside, right? So we go push in, now this one, and then this one, we handled it, and this. All right, and then the K, where's the K? The K is pointing to this, so we got this. So return, what should we return? Do we return I or return I plus 1? No, we return I, right? We return I, which is just one past the valid position, right? One past the valid position. Okay, so then this is correct. So we don't have to, okay, res equals, all right, so we need to do this. This is a repeated string, right? And the new index, right? So repeat string, and the new index will end at either at the end, or it end at this position, right? But it doesn't matter. So so of course res plus equal to count times repeat. I shall equal to new index, right? I equals new index. That's totally fine. I equals new index, which is just pointing here. And K shall equal to I plus 1. Potentially the next one. But actually, K should K. Let me think. Where should K be? K shall be the first one that it's because at the end we'll have the K, right? What if a K come out? I mean, in this case, right? So in this case, we have I equals this, and a K equals this thing. Now K equals here, right? When I come out, I will equal to this one as well. And then goes up, and this whole thing returns. And I and K is the same. And then we return I is here. Okay, let's try this. Oh, I haven't called it. My bad. So what to say? We say return helper 0. Helper 0, 0. Oh, my bad, it's helper. Huh? Oh, it's not self. Wow. And it's not good. The thing is not doing well. All right, these are all pass. I feel a little bit convoluted. But for one thing, I still think this one looks easier. Yeah, I like to just do it that way. It looks easier, right? I'm gonna just say while this. Still pass everything. I skip out everything, and then we get the repetition, get a new index. Okay, and then we have the K. The K is determine the intermediate values come out. Okay, let's try it. Do you want to try some test case? All right, everything has to have a value. Yeah, I think this should be fine. Oh, shoot. Man, didn't see that. All right, I guess it's right. Yep. That's it. Alright, I don't have to check. It took longer than I expected. I thought it's gonna be like 15 minutes. It took us 25. Yeah, it's definitely on the easy side. So I'm gonna just take a look at all my previous solutions. Alright, let's take a look at that. I must have read the discussion already. 394. 394. An old question and an easy one. I shouldn't say easy one. And an easy medium. All right. How about easy medium? I did this a year ago, more than a year ago. How time flies. More than a year ago. Quite smoothly. And this time around, the problem is this time around it took me a bit longer than I had expected. But the basic concept, right? But the basic concept is recursion. We recurse every time a left bracket is encountered. And of course, before doing that, before recursion, we shall have already obtained the number of repeats. And then inside the recursion, we will produce, right, or produce a string contained within the brackets. Now the condition for jumping, right, so jumping out of the recursion is that either S is exhausted or the first right bracket is encountered. First right bracket is encountered. Yeah. Okay, so this one shall run on because everything is encountered once. And we run, is that 28 that this time we got? Wait, got 28. Got 83%. Alright, let's take a look what we have in the past. Much easier. So for letter in S, if this equals the right bracket, expand. We use stack. I use recursion. I think stack is a much better way, right? So if it's not this, stack dot append to the stack. So the first time we hit this, we're gonna pop stack, right? We pop until this. And expand equals stack dot pop. Yes. Once we pop, we do this, and now we pop all the values. Times equals, oh wow, oh my goodness, look at that. And then we join stack. Oh, bravo. This is good logic. I think it's better than what I did this time. This time's like, how should I say it? I feel weird, right? I have to have a K. I don't like a K. Yeah, this is just a stack operation. Yeah, you just push everything to stack every time this one pops out. Then you know you will have another company inside the stack. So you just keep popping stack until you find this, and everything in between does not contain any brackets. So those are the repeating elements. And then you start finding your time. which actually can be done better instead of doing this, right? We can just do int it, and then just times 10 and then plus. That would be better. So just keep popping until, if it's this, we want to pop. So until it's not, but we don't pop again, and we get the number of repeats, right? We got the number of repeats. I put in the stack, but oh yeah, you do put this back into the stack. You do. But why do you say plus equal to though? Why do you do this? I can just append it. Can we append it? I think we can. I mean, what is preventing us from? Yeah, we can. It's just because stack is just string, so we don't have to turn it into a list. I can just append it, and then next time I hit another this, and then this one it pop, right? When they pop, it's just gonna be pop this. Yeah. I hope like I made some modifications. Oh, I mean that the other one was the modified version. One pass using stack. Current string, current number. If it's this, current string equals current stack dot pop, and current string times number of stack dot pop. If it's this, current number, ls. Oh, I see. I remember this one. I remember this one. I should want to do this. Actually, how should I say it? I think I'm gonna do both to honor. So this is my previous method, right? So this is the method I used last year. So we have a stack, and then we just say for letter in s, if letter is equal to a right bracket, right? Pass, else, then stack dot append letter, right? That's a right bracket, and then we're gonna have repeats. So equal to this, that's fine. And then we say while stack and stack, the top is not equal to the left bracket. We just say rep plus equal to stack dot pop, right? And then once we're done, stack dot pop, and then this is pop left bracket. And after that, we can handle all the numbers, right? All the numbers. When we say count is equal to 0, right? So while stack and stack minus 1 is not it's inside, right? It's inside. So to 1 inside this. Then what do? We say when it's inside. We say count equals count times 10. Oh, actually no. Count plus equal to int stack.pop. Oh, that is actually not easy to do because we're going backwards. So the next one need to go every value times 10. You don't know how many 10 you have to time. Ah, this is, now I see why I must have encountered the same issue. Okay, that's fine. That's fine. So count equals stack.pop, all right? Add count. We'll pop it out, we'll push in the front. Basically, just push in the front, right? And when this is done, we'll just say stack.append, right? .append rep int count times rep, right? And at the end, we say return join stack. Let's see if this one's correct. I'm missing. Okay. Huh. That is weird. So we got 3A and CB. Oh. And what happened? The repetition. Hold on, let me think. Let me think. So every time we pop, right? And we pop, we add it to this. So we have to do like this. No, rep. Yeah. So that is this, the old solution, and also we can do a one pass, which we have. Well, this one will have like 6 submissions. All right. Oh, we got it wrong. What? That is crazy. Oh. Wait. Oh, I did put 0. Shoot. Yeah. Oh, wow. Look at this. This is even faster. I made small changes, and it runs at 20 milliseconds, 99% ranking. Wow, I haven't get 99 for a while. All right, this is a one path, the so-called one path solution. This must be from the discussion with one pass, not one path, with 2 stacks. So we have str stack, right? And then we have a num stack, so 2 stacks, okay? So for letter in S, we say if 0 to 9, right? Then num stack.append letter. Elif letter is oh, we also need a current string, right? Hold on, let me think what this one does. So if it's this, then str stack, we push this in, okay? So when we go blah 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 blah, and once this, and whoever is inside. Hold on, let me think. So we have a current string, right? The current string is the current. So basically, we're gonna have, I don't know what this one's gonna do, but we know else is gonna be current plus equal to s plus equal to a letter. So we have a current string, which is just a running string that's currently have. So we have a current string. So Aleph, if Aleph letter is equal to, let's say, the left bracket, right? If equal to left bracket, then that means my current string is ended, right? It's ended. So we say str.append current string and a current back to this. And Aleph letter is equal to the right bracket. And now we go in and then blah 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 and equal to the right bracket. So whatever the current string it is, need to whatever it is, need to change. So what do you mean by change? What I mean by change is whatever I have a current is going to be duplicated, right? Because I hit a right bracket, and the current string is the current running string. When I hit the right bracket, the current running string needs to change. Now, how do we change? We need to go to the numbers, right? Because the numbers, we got push, and whenever the first left bracket is encountered, that is not right. So we have, okay, so we have the current str and a current num. So on this is going to be current num plus equal to current num is actually going to be 0. Current num times 10, right, plus int letter. And then once we hit this, and then num stack.append current num. So these two are, corresponding to each other. Now it makes sense. Current str and a current num, they will both reset. And once it's this, right, then we just say doing the rest. So once we hit a right bracket, then we say, what do we say? We say, do we get the thing out from the stack? We get out from the stack. Then what? And then we will do num times this, right? What do we do after that? Do we push that back into the... Hold on, what if I have like this situation, right? So we count the numbers, left bracket, I don't have any current str though. Left bracket. No, I don't think this is right. If the left bracket happens, then we shall... If the left bracket happens, whatever current we are collecting, shouldn't that be going directly into... Hold on. So we have a left bracket. We do put the number in, right? And then what? And then we will collect A, right? And then we'll put a number, and both go into the stack. And now I collect C, right? Collect C. That's current str is C. So we'll pop this one out. We'll pop this one out. We'll get CC. And then we'll also pop the stack. So once this happens, Once the right bracket happens, we'll pop it out and push in once the right bracket happens, we have current str is the current value, right? And we're going to pop from the num stack, that will correspond to this. So we do that. And after we do that, then what do? We need to combine with the previous. Now the previous one is in the stack, but that shall be before. So what we'll do, we pop that and add a current. That's the new current. Is that what it is? Okay, so this is my understanding, right? So my understanding is whenever I hit the left bracket, I do append the current str, right? No matter what, I do append the current str. I do append the current str. And we also do the number, also append the current number or reset. Once we do this, right, then what we do is we need to have current num st.pop times current str. So that is whatever is inside the bracket, right? And then this thing is done. Then we want a new current, right? We want a new current. So the new current happens by popping on str stack. So this one is actually be here. str stack dot pop plus this, that will be the current str, or equal to this. Okay. Current str. So when we return, we'll return current str? Is that what it is? Man, actually I'm not sure. Oh, I think it is. Wait, let me see. Is that how it is? I can try it. Because I don't feel this is right. It feels strange, right? It feels very strange. All right, I'm gonna run this code. It might pass. It does pass, but I'm curious. All right. Nope, that's not the one. Which one did it open? It's the one I solved today. Come on, man. Is this one? No, that's the one I solved today. Is this one? If it's a left bracket, pop. If it's right bracket, pop. Hey, it was correct. Oh, that's actually exactly the same. Oh, wow. Yep, so this is correct. This is correct. Huh. I was going to say it is correct. I was gonna say it is correct. What the hell? What the hell? Wait, hold on. as 1, 10, 100. Yeah. And now we hit this. Current str is going to be, now current str is empty, so str.pop is going to be empty. It's going to be a 100, right? And then reset. And then next one is LeetCode. It says current str. And we hit the right bracket. Current str is equal to number pop, that's 100 times. Wait, how is this one not right? Diff. Huh? I'm outputting more. Wait, what? You're kidding me, right? This is exactly the same. Like literally this, I think this is exactly this. Like you can tell the difference. Well, I do tell the difference. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of them will output more. Okay, let's count. 121. 121. 121. How'd you figure? It was the same code, right? No, it's not the same code. Something is not right. Something is not right. And it's on me. Hold on. This is weird. Alright? This is weird. Let's try to see if we can find out what went wrong. Apparently we got more. Right? We handled the number wrong. Current number times 10 plus. That should be fine. Right? I mean, easy, we just print. Let's print num st. Let's see if num st is 100. Name solution is not defined. Of course it's not defined. 121. Oh. I am very sorry. Oh my goodness. Oh my goodness. I was like, this is exactly the same. No, it's not exactly the same. You have, all right, I don't even want to say. That's, okay. All right. That's it. That's it. That's it. That was funny. All right, how did you get to 121? I mean, how do we reason about it? So basically, the num will add to this, right? So the first round, this one plus equal to, so num equals this thing. So the first one is 1, and the second one is 10, right? So second one become 11. Yeah, the second one become 11. And third one is 110 plus 11 is 121. Yes, that's why. Dumb, stupid, and dumb. All right. I'll take a look. You don't want to save your mind, save your brain. Oh, I want to, but I'm just curious. I just see how difficult it is. Right? Elimination Game. Just read it. Just read it. All right, just read it. I'm not gonna do it. I just read it. Preparing for tomorrow. Well, actually no, because today I think that the contest is gonna be 5 questions, and any of the questions that I couldn't do, I think I'll just do in the tomorrow, something like that. All right, I have a list of array of integers in the range sorted in a strictly increasing order. Okay. Apply the following algorithm on an array. Starting from left to right, remove the first number and every other number afterward until you reach the end. Repeat the previous step again, but this time from right to left. Remove the rightmost number and every other number from the remaining numbers. Keep repeating, alternating left to right and the right to left until a single number remains. Give an enter to the last number that can remain. So if it's 9, if I go, these are removed, right? First number, so all the even positions, 0, 2, 4, 6, and 8. So remaining 2, 4, 6, 8. And then we remove 8, 4. Then remove 2. And I give a gigantic value, so there has to be something mathy, right? Something math like. All right, so the first round remove. And if you look at the number itself, it's gonna just be even or odd, right? So first round gonna remove all the odd numbers. No matter what, you're gonna remove odd numbers. So when I remove the remaining is just gonna be even values. But the even values, to look at it, it's 2 times 1, right? 2 times 2, 2 times 3, all the way, right? And then we're gonna remove all the from right to left, so all the odd values, right? So 2 times 4 and 2 times 2 removed. And the next one, we got 2 times 1 and 2 times 3. And we're going to remove all the even ones, which is 2 times 1. Next one is 2.5. Anyway, so we will remove all the even numbers, odd numbers in the first round. So now we are getting 2 times 1, 2 times 2. So basically it's 1, 2, 3, 4 again, but with 2 times everything. Okay. So with this, then we're gonna remove from right to left, so all the even will be gone, right? So now the remaining is 2 times 1, 3, 5, 7 all the way down. Next, now it's just going to be removing 1, 5 something, and removing. Oh, it's not. I thought I can use 2, but after 2 rounds, it's not that obvious. Let me write it out. Let me write out another sequence. One, 2, 3, 4, 5, 6, 7, 8, 9. How about 10? How about 11? Let's write out 11. So first round, all of these, right? Second round, oh, hold on. Second round is after the first round is gone. So we will go this, and skip this, skip this. Nope, that is not correct. That is not correct. I'm doing it again. 2, 3, 4, 5, 6, 7, 9, 10, 11. The first round is all the odd numbers gone. Right. Second round, from right to left. Right, so 10 will be gone. But we also have to skip. So 10 gone. Basically, it's 2, 4, 6, 8, 10. So 10 gone, 6 gone, 2 gone. 10 gone, 6 gone, 2 gone. So your remaining is 4, 8. And we'll remove 4. So the answer is 8. So in this case, what I'm seeing is, I'm going to do one more example. One more. Even more comprehensive. Let's go all the way to like maybe 20 something. They're really big, right? Really big, so I can see the pattern. I feel like there is a pattern. All right, let's go to 20. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I'm going to remove all the odd values. Okay. Right? Remove all the odd values. And then I'm going to remove all the even values. No, we're going to do it again. So we're going to go remove, skip, remove, skip, remove, skip, remove, skip, remove, skip. So what happens is for one thing, I might as well add 21 because it doesn't really matter. Right? So if n is an even number, we can turn the even number into odd number. So only thing we need to consider is odd number, right? So once we do that, after 2 rounds, we're removing 3 by 3. So from the right side, take out 3, gap, 3, gap, 3, gap, 3, gap, 3, gap, some other value, all right? So once this is done, this is the second round, and the third round, if you think about it, we remove one value, right? And then that's an odd value. And then we're going to remove an even value. So an even value is going to be to the left. Well, it depends. But it is. If we have even, odd, even, odd at the end, right? Now we remove the even value. That's 3. That's 3, right? And then we remove it. That's 3. So that's all 3. So now we're going to remove again from the start. Okay, from the start. So we remove this, skip, this, skip, and this. Now look at what we have. We have 1, 2, 3, 4, 5, 6, 7. We have 7 got removed after 3 rounds. And we have 1, 2, 3, 4, 5, 6, 7 got removed after 3 rounds. And a 1, 2, 3, 4, 5. That's only 5 in the beginning, which is bullcrap. I don't want 5 in the beginning because it's limited. Because there's nothing to the left that I can go. So there's no even an R on the left. So you're saying the front will always be smaller. And now we have 2 values left, right? And it depends on which round is its front. So we can remove 14. The result is 6. Wait, hold on. 21 result is 6. So we say 20 and 21 shall be the same value. Actually, all of these should be the same value. Six, 6, 6. All right. Okay. So I think this is follow a pattern. Let's add one more value. Let's add a 20, 23. All right. So if we say we added 23, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So again, first round. Okay, the second round, we're always going to go 3, right? Skip 3, skip 3, skip 3, skip 3, skip 3. Oh, look at this. Now it's different. All right, now we're going to go start. So in this case, we have 3, 3, 3, 3, 3. Everything is 3. And now we're going to do this. That's going to be 7, skip 7, skip 7. And then next one, so that should be 8, right? Which 22 and 23 both are 8. Nice. They're both 8. What if we go to 24 and 25? Or if we go to 24 and 25, I think it'll be repeating of the previous example. So the first round, we'll remove all ones, right? And the second round, because we're starting from the second round, will be this. So it'll be 3, right? Gap 3, gap 3. So basically 3 gap 3, that's 4, right? 4. Then we can count at the beginning. If it's 25, 25 divided by 4, we have 6 of them, right? It's going to be 3 and a gap, 3 and a gap, 3 and a gap, right? And then 3 and a gap. Right, because it's 25. 3, so it's supposed to be 3 and a gap, 3 and a gap. So eventually, what's going to happen? So 3 and a gap, 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 3 and the gap. So 1 is the front, and then we have 2 is the one that's not removed, is the gap, right? And then we have so 1, 2, 3, 4, 5, 6, right? So 3 and a gap, 3 and a gap. And the next one is from this, right? From the start. So we know the starting number. And then we're gonna remove again. But the next round when we remove, it's gonna be 7, right? So we say we do this and a gap. So that's the gap. 3, 2, 3, 4, 5. That's 6. And then we have as a gap, and then 7, right? And a gap. 7 and a gap. So how do we count that? Well, we count that by finding, because that's going to be the start. The next is, so that's going to be the 6th one, right? The 6th one in this case, because we start at 2, and we know that's going to be the 3. So that's 5. So the 6 is going to be this one is going to be spared. And everything going down is going to be every 8 values. Right? Every 8th. So with the 6 plus 8 is 14. Going to be spared because that's the 8th. Right? Because I'm going to 7, that's 8th. And a 7 up to 22 will be spared. Right? So once we hit there, the next round, we're going to start from 22. Right? Going to start from 22. And we'll start from 22. Now we have 7 in the gap. So the next one, because that's 8, right? So next one is be the 7 plus 7. Yeah, because be 3 plus 3 plus 1. Right? That gives us 7 is the gap. Now we're gonna have this one, get it, and I have 7, and we skip, and then we do this, right? So now what? Now in total we're saying man, I seem to have found the pattern, but I'm lost in it. I'm losing it. Well, the gap between them is 8. Right? The gap between them is 8. And now we're starting from 22, right? And let's just say 22 to the end, right? Also has 7. So 7 plus 7 is 14, plus 1 is 15. So the gap now is 15, right? Gap now is 15, which means from 22, the next one I'm looking for now is 16, because I need to add 22 itself. That's going to be 16, which means from 22 to my next value to be removed, right? To be removed. To be removed. To be removed. 22 minus 16, that is 6. Right, so 6 is going to be removed. How do we know 14 is left if we don't consider 14 to start with? And remember, we have a 10 to the 9th. Right? That's a lot of values. So I say I know it's from 6 and every 8 values, right, is remaining. Is remaining. We want to calculate the remaining, right? So 6, so we now 22 is going to be done. So we're going to say 22 minus hold up. That's the first value is going to be deleted, right? So if that's the first value to be deleted, how do I find the value next to it that is not going to be deleted? So which is the previous gap, right? So that's why we say 2 plus 4 is 6. 6 is the starting value with 8 gap, right? So this one we can calculate the last value is just going to be 6 plus 8 plus 8 plus 8. So it's just the total value. Right, so the total value is 25. So we say it's going to be 25 minus 6, which is 18, divided by 8, which is 2. So we know we can do 2 rounds. So 2 times 8 is 16. So this one will end at 22. Okay. So now when I start at 22, at 22 we're gonna find the first surviving value. So we're going left. So 22 into minus 8, right? So 14 is the starting value, and now the gap becomes 16, right? And from 14 to 16 is nothing left, so that's why the answer is 14. Okay, so let's summarize it. So we start from 1, right? We start from 1, and the gap is 2, right? And this one, let's do another example. How about let's do example of, what do we say, 100. How about 100? And doesn't matter, we can do 100, right? So we can say 100, right, minus 1 divided by 2 is 49 times 2 plus 1. So the last value, 2b, it's actually not right. Let me do it again. I want to see which one is remaining. So we start at 1, and we know that the gap at the beginning is actually 1. The gap at the beginning is 1, right? So we start at 1, and no, the first one we just start with 2. We start at 2, and the gap is, we start at 2, right? And the gap is actually 1 because in between them, wait, hold on. What is the gap? Gap is between me and the left. The gap is 2. We start at 2, right? And the gap is 2, and we're going to the right. We're going to the right, and we say how many left? So we say 100 minus 2, right? Divide by 2, and then 100. What are you doing? 100 minus 2 divided by 2 times 2 plus 2, right? So this one will end at 100. So 100 will be the one that's left after the first round, right? Second round, we start with 100, but we need to remove it. So 100 minus 2 is 98. 98 is the first one that's remaining, but now the gap becomes 4 and going to the left. So we're going to compute how many we can get. So how many we can get? We have 100 value in total, right? And we start at 98 going to the left. We want to know what. So it's going to be 98, right? And the gap is 4, right? So it's a 98, and next one, so it's going to be 98 divided by 4. So 24 times 4, 96, right? So what we're saying is, so what's the first value? 98 divided by 4, so 24. So I have 24 times 4 is 96. So we have 2 left at the front, right? So it's 98, 94, all the way towards 2, right? All the way towards 2. Because what we know is the first one. So basically it's going to be the first one, whatever first one, right? And then we say, wait, how do we calculate this? So 98 divided by 4, right? That's 24. So 98 divided minus 96. So we're going to start with 2, right? So start with 2. So this one will give us 2. Will be the value that's remaining. Okay? So 2 will be the value that's remaining after we're going left for 4. And next one, we're going to start with 2, right? But plus 4. We start with 6, right? We start with 6. And then the gap now becomes 8. So let's see which one can we reach. Which one can we reach? By 6. Shouldn't we end at 98? Yeah, we should actually end at 98. So it's up to 98. Which one can we reach? So 98 divided by 6. no, divided by 8. No, wait, 98 minus 6. So that's the total number in between, and divided by 8. So it's 11 times 8 plus 6. So we end at 94, right? Okay. So now we can 94 is the last one. 94 gonna go. So we're gonna go left. So 94 minus 8. What's 94 minus 8? 86. So we're gonna start with 86, and now the gap is 16. Okay. So from 86 going down, and then the last value we can reach. I don't even know which one the last value we can reach should be 6. But before 6, right? So it shouldn't be 86 minus 6 as the total value in between, divided by 16. Give me 5. Give me 5, right? So 16 times 5 is 80. So 86 minus 80 give us 6. So this one will go back to 6. Okay? So now 6 is going to be removed. The 6 plus 16, so we're going to start with 22. Now the gap becomes 32. Right? Now we're going to reach all the way to 86. So we say 86 minus 22, whatever it is, divided by 32 is 2. Right? Is 2. So we say 32 times 2 plus 22. So this one's going to reach 86. Okay, so now next one, 86 minus 32. So we're going to start with 54, going to the left, and our gap becomes 64. And our end is 22, right? So we say 54 minus 22 divided by 64, which is 0. And that's it. We end with 54 as a survivor. So let's say 100. Let's see if that is 54. That is 54. Okay, so I think this might be right. Okay, I didn't want to do it, but I think we might have it. We might have it. All right, boys. Let's try this. Let's try this. All right. So what I think is we're gonna get the start, right? And then we'll go left or right. So go right is gonna be 1, right? And then while true. So we're gonna say the starting value. Okay. So go right, starting value, and gap. Right? So the starting value is going to be 2, and the gap, starting gap is 2. Actually, should the starting value be 1? Think about it. Starting value is 1, and gap is 1. All right? No, we say 1 is the one that survives. But 1 never survives unless n is equal to 1. How is output 1 if n is 1? Okay, that is weird. If n is 1, array is 1, and I start from the left or remove the first number, the last number remains. How is it 1? If n is equal to 1, right, we only have 1 element in it. Oh, then we don't remove. Ah, that's why. Okay, That's just a special case. If n is equal to 1, return 1. Otherwise, start in gap, right? It should be fine. And then, okay, we're gonna say if go right. Okay, if, yeah, I'm pretty sure it's when do we end? That's a good question. When do we end? We'll always go, well, we end once we cannot go anymore, right? When we cannot go anymore. So, yeah. So we say if go right, and just see if we can go, right? If we go right, then, oh, we need to also have the range. Shouldn't just be left and right. It must be left and right. So this is the left, right, and a gap. All right, so go right, left, right is n, and gap is 2. Okay, so if go right, which is start, then we just say we're gonna find the right, new right, right? The new right shall equal to right minus left divided by gap, right? And then this thing times gap. Divided gap is how many I can do, and then times gap, and then plus left. So that's the new right. And then we say if that is while left is smaller than right. Go right, this is a new right, and then, yeah, hold on. That is the right, right? That is the right. It's the right value, So if go right, all the way go to 100, right? And in that case, is we cannot even find. So, I'm gonna do true. I want to check here. Basically, if say a left equals right? That means just we cannot go at all. Then we return left, right? If we can go, then right equals to, right will be minus equal to gap, and then gap times equal to 2. Then we go back up. Else, if go right is equal to 1, why don't you use true? Yeah, we can say true and false. So while go right, and then go right equals not go right, So it'll be false, right? So else, I will go left. I will go left and then calculate the new left. So new left will equal to what? New left will be right minus left divided by gap times, no, not times, divided gap, times gap, yeah, actually the times, and then we say right minus this, right? So that will be the new left. Again, if left equals right, which means I didn't move at all, I return left. That's really return right. It's the same thing. And then once it's done, so we find the new left. The left need to be plus equal to gap. and then gap times equal to 2. Right? And I just realized that gap always time is equal to 2, so I don't have to do. I'm going to do here, and goal right is not equal. This one always happens, so we're going to do this one as well. All right, and then that shall be it. All right, we have a bunch of test cases. A good part of this type of problem is have lots of test cases. 9 shall output 6. 1 shall output 1. I don't have to test 1. 1 is obvious. It's trivial case. 2 shall output 2. Right, and test 3. We have 9 shall output 6. 20 shall output 6. What else do we have? 21. And then 21 is also 6. Yeah. Next is 23, 22. And then 22, 23 is 8. That's why I said 100, 54. Okay? Yeah, I kind of don't want to do the test today. I'm lazy. This one takes too much of my time and then take a lot of the energy. You want to go? No, I don't want to go because I want to try the 1, 2, 3, 4, 5, 6, 7, 8, 9. How about this one? All right, just to see if it works. It does. Let's go. Booyah! Very slow, but we got it. Ah. All right. Why would it be slow? I mean, maybe we can simplify this. What are we trying to do here? I take a divide and then to multiply it again. So I'm taking the integer, right? So basically it's hold on, what is this? Isn't that just the remainder? Yeah, it's like just this one minus the remainder. Why not? So so the idea is to write out a few examples and look for the pattern, right? So the pattern is always that the gap between the remaining values are doubled after each round. Thus, if we can keep track of the first remaining value when we go from left to right, and the first and the last remaining value when we go from right to left, we will have found all remaining values. We can keep this process until there is only one remaining value after a round. This is like we split in half, so I would say it's O log n. But why I score so badly, I have no idea. I have 58 milliseconds. I only got 20%, 19%. All right, we have 10 more minutes before the contest. Shall we do it? All right, let's do it. But before doing it, easiest, login, clear breakdown, one-line solution. What? All right, I'm gonna end it right here as I'm reading through this. I'll see you guys tomorrow, and I'll kind of report. I'll see if I